The topic of this presentation is fundamental of reinforcement learning. Here we will understand what is reinforcement learning. Then we will look into how does RL works, where we will see the mathematics behind it. At last, we will see what are the difficulties in RL implementation. The topic reinforcement learning comes under machine learning. So first we will understand what is machine learning. In classical programming, correspond to data input to find out the correct answer. Some rules are given to it along with the data input. But what if these rules are not known to us? This is where machine learning is useful. In machine learning, for the examples for which correspond to data input, we know the answer. Such examples are used to find out the rules. So this is what machine learning is. Now I wonder how we human learns. To understand how we human learns, let's take a simple example. Here there are two people who are meeting for the first time. Let call this person to be first person, the other one to be second person. The first person objective is to have a engaging conversation with the other one. To do so, he need to know the topic on which the second person might find it interesting. But as they are meeting for the first time, he would not know. In machine learning domain, this is called as label data is not available. Then the second solution is to have a mathematical model of the second person so that by looking into the mathematical model, he would know the nature of the person, how is the behavior of this person, and based on this, he would have a good conversation. But it is not possible to have a mathematical model of any human. In machine learning domain, this is called as physics is not available. Then how we human learns in spite of not having the label data, not having the physics, then how we human learns? What we do based on the experience we get by interacting with the other people's, based on those experience we learn, and we take decision in future conversations. And so in short we could say that decision is taken based on average of past experience. Why average? Because we do not have just single experience but we have many experience, that is why average. Now we have understood what is human learning. If in the same way the human learns, if in the same way if we could make machine also learn, then in machine learning domain this is called as reinforcement learning. Now we have understood what is reinforcement learning. Now let's look at the mathematics behind it. Here we have taken same example, but now the first person is not a human, but let's consider it to be a machine or a robot. Then the second person is a human, which is represented by f5, whereas the first person is represented by the function f theta. The second person speaks a few words to the first person represented by the variable p2. Based on the word p2, the first person responds with variable p1. Then, based on the variable p1, the second person tells the first person for what duration time he is interested to have conversation, represented by variable d. Here, the objective of the first person is to have a conversation for longer duration of time, that is d. Let's represent this thing in a mathematical expression. So here the objective is to maximize d, that is duration, and optimize the parameter theta of the first person. As this is maximization problem, you would update the parameter theta by using gradient ascent approach. Here the gradient of j could be written as gradient of d, where d comes as an output from the second person function, that is f5, which takes input as p1. p1 comes from first person function f theta, which takes input as p2. Now taking gradient over this term, we could update theta and find the optimal theta value. But there is one issue. We cannot take gradient over this term. Why? Because as said on the earlier slides, we do not know the physics of the second person. Not knowing the physics of the second person means we do not know the F5, and as a result, we would not be knowing the functional form of this whole term, which would make it impossible to take a gradient over it. If this is the case, then how do we human learns based on the experience we get, that is D? There is one thing which we missed. We learn not just based on the experience, but we learn based on the average of the experience. Secondly, we human think in a probabilistic fashion. Why? Because everything which happens around us is of random nature. So this P1 would be random, P2 would be random, and also D would be random variable. So in statistics, taking average of such a random variable is called as expectation. So now our this objective function would get modified and would be written as expectation of D. Here expectation of D could be written as integration of probability density function of D into D, integration with respect to D. Here this probability density function could be written as joint probability density function, written as integration of probability density function of D, P1, P2, integration with respect to P1, P2. Let's now take D inside. Here we have three random variables, P1, P2 and D. Let's represent this random variable by a single X variable. Now let's look at what would happen by taking gradient over this objective function. The gradient can be interchanged with the integral. Here doing integration is not possible. Why? Because PDF probability density function is the form of the probability density function is not known to us because the physics of the second person is not known. So we need to approximate this. To approximate this, one way is to do a Monte Carlo sampling. To do so, we need to have a PDF function over which there is no gradient so that we could write this term in terms of expectation. So let's multiply PDF function in numerator and denominator. Now this could be written as expectation. So now we have written this as expectation where this term gradient of P divided by gradient of PDF function divided by PDF function is written as gradient of log. Now as we have written this as expectation, this could be approximated using Monte Carlo sampling. Now here we have solved the issue of integration, but there is now one more issue, that is gradient can't be taken because PDF is not known. So let's expand this PDF function based on the dependency in a random variable. Here PDF of P2 is multiplied with PDF of P1 given P2. Why? Because P1 depends on P2. Then it's multiplied with D probability function of D given P1. Why? Because D is based on P1. As this term is inside log, we could write in terms of summation. Now here, this term is not a function of theta, it is a function of only phi. So as this is not a function of theta and we are taking gradient with respect to theta, this whole term will become 0. Now finally, the solution which you have got is not parameterized by parameter phi and its parameter is only parameter theta. As a result, this the gradient can be taken over this term and we can find the optimal parameter theta. Now we could see that without knowing physics, we are now able to find the parameter theta using this gradient over J. In spite of having this solution, researchers took many decades to be able to make reinforcement learning useful for a practical application because of few difficulties. In the derivation, we saw that we were not able to take the integration, because of which we approximated it using Monte Carlo sampling. Now, to do a good approximation, we need to have many Monte Carlo samples. Many Monte Carlo samples means requiring many number of interaction with the second person, which is not practically possible. The second issue is learning in a safer manner. In reinforcement learning, we do not have any prior knowledge. As a result, during training, the we take random decision, and because of which it may happen that the first person, which is robot, could hurt the second person's sentiments. As as it as in our example, it was a verbal interaction. But for the scenario where there is a physical interaction, it may hurt physically also. Thank you for attending this presentation. I hope this presentation was helpful in understanding this topic, reinforcement learning, in a simplified manner.